today, let us look at section formula in coordinate geometry. We have the xy plane. You can see the x and y axes. Now let us take a point A on the origin, which has a coordinate 0, 0. Let us take another point B with the coordinates 6, 4. Now let us join the segment AB. Let there be a point C on this segment. Let its coordinates be 3, 2. Now in what ratio does the point C divide the segment AB? In other words, what is AC is to CB? To find that out, let us draw perpendiculars from points C and B onto the x-axis. We can see the right angles, which are angle D and angle F. And here are a pair of corresponding angles, where CF is parallel to the x-axis and AB acts as the transversal. We see that there are two similar triangles in the given figure. So triangle CAD is similar to triangle BCF due to AA similarity. Now we know that in similar triangles, the ratio of the corresponding sides is equal. So AD by CF should be equal to AC by CB. We can see from the figure that AD is equal to 3 units and CF is also equal to 3 units. Look at the x coordinates. The intercept AD on x-axis is equal to 3 units. And the segment CF is equal to the segment DE, which has an intercept of 3 units on the x-axis. This gives us AC by CB equals 1. Or this also means that AC is equal to CB, which means that C is the midpoint of segment AB. Now say the coordinates of point C were unknown and we were given that C is the midpoint of AB. How would we go about finding the coordinates x, y corresponding to this point C? Now let us redo the problem but in the opposite direction. Now we can see two similar triangles as we saw earlier. So triangle CAD is similar to triangle BCF. We can see from the figure that AD would be equal to x units, right? Because D corresponds to the x coordinate of point C. Similarly, we can see that segment DE would be equal to 6 minus x units. Again, let us look at the x-intercepts. Now, since these two triangles are similar, we can say that the ratios of the corresponding sides would also be the same. So, AC by CB would be equal to AD by CF. We know that AC equals CB since C is the midpoint. So, we get AD by CF equals 1. Or AD equals CF. Let us substitute the values in terms of x. So we get 6 minus x equals x. We can solve this equation in one variable to find that x equals 3. Now let us draw perpendiculars onto the y-axis and let us look at the y-intercepts this time. So AC by CB would be equal to CD by BF. We can see that CD would be equal to y units and BF would be equal to 4 minus y units. So we get AC by CB equals y by 4 minus y. However, AC is equal to CB. So y shall be equal to 4 minus y. We can solve for y and it comes out as 2. Now this figure was very easy to read because one of the points was the origin itself. What if A was not on the origin? Let us shift the segment AB somewhere in the first quadrant. Now let us call the coordinates of point A as x1, y1 and the coordinates of point B as x2, y2. Let us say there was a point C lying on the segment AB with coordinates x, y. Let us also say that this point C divides the segment AB in the ratio m1 is to m2 or AC is to CB equals m1 is to m2. Similar to the previous case, let us draw perpendiculars onto the x-axis. Now let us look at these two similar triangles. We can also draw perpendiculars onto the y-axis as we did in the previous problem. Now looking at these similar triangles, let us look at the ratio of the corresponding sides. So AC by CB would be equal to CJ by BH, which would be equal to AJ by CH. Substitute AC by CB by M1 by M2. We can write the lengths of the segments in terms of the y and x intercepts. So CJ would be equal to y minus y1 and BH would be equal to y2 minus y. Similarly, AJ would be equal to x minus x1 and CH would be equal to x2 minus x. Now we have two equalities. Let us take first two parts of this equality. So we have m1 by m2 equals y minus y1 by y2 minus y. Taking the first and third part of the equality, we get m1 by m2 equals x minus x1 by x2 minus x. Now let us cross multiply and find the values of x and y, the coordinates of point C in terms of the coordinates of points A and B. So we get y equals m2y1 plus m1y2 divided by m1 plus m2, and we get x as m2x1 plus m1x2 divided by m1 plus m2. Now this formula for finding the coordinates of point C is known as the section formula. Let us recall that we only looked at similar triangles and ratio of their corresponding sides. Now let us see how to apply this formula. Let us look at a problem. Find the coordinates of the point which divides the segment joining 7, minus 1 and minus 3, 4 in the ratio 2:3. Let us draw a figure and try to understand this problem. So we can draw points A and B. Now let us join the segment AB and we have to find a point C. Let us call its coordinates x, y, and we are given that C divides the segment in the ratio 2:3. So AC is to CB would be equal to 2:3. Alright, let us write down the section formula. Now let us call the coordinates of point A as x1, y1, the coordinates of point B as x2, y2, and the ratio of AC is to CB as m1 is to m2. Now this becomes simple. We just have to substitute these values into the section formula. We find that y equals 1 and x equals 3. So the coordinates of point C would be 3, 1. Let us verify that from our diagram. We can see that the point C has an x coordinate 3 and a y coordinate 1. Brilliant. Let us look at another problem. Find the coordinates of a point C where CB is the diameter of a circle whose center is at A 2, minus 3 and B is 1, 4. Okay, so we are given the center of the circle and a point on the circle. So let us join these 2 points to form the diameter BC. Now let us call the coordinates of point C as x1, y1. The coordinates of point A would be x, y, and the coordinates of point B would be called x2, y2. Now we know the coordinates of point A and point B. And since A is the center and BC is the diameter, so A would be the midpoint of the segment BC. So M1 is to M2 would be equal to 1 is to 1, since the two segments would be equal. Now let us write the section formula and substitute the values. We find y1 equals minus 10 and x1 equals 3. So my point C would have the coordinates 3, minus 10. Let us verify this from our diagram. Yes, it comes out as 3, minus 10. Let us look at another problem. If the points A 6, 1, B 8, 2, C 9, 4 and D P, 3 are the vertices of a parallelogram taken in order, find the value of P. Now it is not necessary, but let us draw a diagram anyway. So let us plot points A, B, C, D. Since we don't know the coordinates of point D, let us try to draw a parallelogram and guess what point D could be. Now which properties of a parallelogram are we aware of? We know that the opposite sides of a parallelogram are equal. We know that they are parallel. But how do we use the section formula here? For a section formula, a segment needs to be divided into two parts. Why don't we try to draw the diagonals? The diagonals BD and AC would intersect at a point E. Now we know that the diagonals of a parallelogram, they bisect each other. Hence, E would be the midpoint of these two diagonals. Now let us apply the section formula for both these segments, AC and BD. Since E is the midpoint, we would have M1 is to M2 equals 1 is to 1 for both the cases. Alright, now what we're trying to do is we're trying to find the coordinates of point E. So let us look at segment AC first and try to find out the coordinates of point E with respect to A and C. Let us substitute the values. We get point E as 15 by 2, 5 by 2. Now let us do a similar exercise for the segment BD. Let us substitute the values and find the coordinates in terms of P. Now we know the midpoint of AC and midpoint of BD are the same, so we can equate the x coordinate of both these points. Solving this equation, we get P equals 7, which means that the coordinates of point D would be 7, 3.